All right, the next example from 0 to 0 to 2, and then 0 to 1 of 6xy dy dx. All right, now this time the function is very hard to draw, right? This is the integrand 6xy, and so it kind of like goes this way, and this way. It's going to be a curve, okay? I mean, it's going to be a surface, and it's going to be a smooth surface. 0, 0, this is of course 0 everywhere here, and it just grows, you know, from here, right? And then we are trying to integrate this as what? X goes from 0 to 2, 1, 2, and then y goes from 0 to 1, right? So it's this region over which we are integrating this, right? It doesn't matter what the graph looks like because we can do this numerically or just using mathematics or integration, right? So again, when you do this first part, this part here, keep x fixed. So think of x as a constant when you integrate with respect to y. Now you are used to doing this because you already did partial derivatives many times, right? And so think of and pretend, and you're good at pretending now, pretend like x is a constant at this point. So what happens when you think of integrating 6xy with respect to y? Well, x stays the same. 6y becomes 3y squared, right? So the first part, you get 3xy squared, and y goes from 0 to 1. So y goes from 0 to 1. You don't always have to write y equals here, but it may help at the beginning because you may be confused, like, oh yeah, I'm supposed to plug in 1 and 0, but where? You know, is that x or y? Remember, it's y first. So when you plug in y, you get 3x, and then 1 minus 0, 1 square minus 0 square, technically. All right, so this is 3x dx, and from now, I mean, at this point, it's much easier. 3 over 2 x squared, going from 0 to 2, that's 3 over 2, 4 minus 0, and that is 12 over 2, and that's 6. Okay, so that's the area. I mean, sorry, that's the, how do you interpret this? It's the region under this surface, 6xy, over the region R. So it's the area of the volume bounded by the xy plane and this function 6xy over the region. This region, by the way, can also be written as Cartesian product 0, 2 cross 0, 1. And that would be the region. Okay, or you can also write this in the reverse. So let's change the order. Now, why do I do that? Well, you don't have to, okay? But it turns out, switching the order turns out to be a very important skill. And in fact, you'll spend a lot of time in this chapter switching the order of integration because it turns out some functions cannot be integrated in one order, but can be in the other order. It's tricky, right? So you have to be able to switch the order of integration. And of course, you have to pay attention to these little numbers too, right? Because if you switch the order from dy dx to dx dy, then these numbers also change, dx dy in this order, right? So if you write it this way, then what is the integral or antiderivative of 6xy if y is constant and x is the only variable? Well, this becomes 3x squared, and then y just comes along, right? And then x goes from 0 to 2. So this is the way we have to plug in. Remember, x is the one that goes in here. So 3y is still constant, and x goes from 0 to 2. So x squared goes from 0 to 4. And this is what you get. It is 12y dy as y goes from 0 to 2. That's 6y squared from 0 to, that is not correct. So, okay, so you know that this was supposed to be a 1 here. Yeah, and I knew that. I just didn't write 1. All right, so this is 1. All right, so 12, and so 12y becomes 6y squared. And this is, of course, 6, right? You get the same answer here, naturally. Okay, next, find what this integral represents. All right, so this is a visualization exercise problem. Okay, what does this represent? Okay, you found this. My favorite illustration. You and your friends are walking on the sidewalk. Okay, and you pick up a sheet of paper, and on this piece of paper is this mysterious code. And your friends freak out and say, "Man, this must be some secret message by a terrorist or something." And he said, "No, no, 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 no. This I can sketch this, right?" And so of course it's not. So how do you do that? What does this represent? Okay, you can say it does represent a volume of a solid under this curve, a surface x squared plus y squared, right? What does x squared plus y squared look like? Well, you say, yeah, that's going to be a parabola, right? See that? Right? Because I mean, you can do traces if you like. You can trace this and then this one here. All right. And so what this is saying is you go from 0 to 1 in both x and y direction. And so what does it do? Well, maybe it's this point, and basically what you're saying is you have a and 1 1 will be represented by this point. You have some sort of a solid here under this paraboloid, okay, and over this xy plane. So the area would look like this, right? So this would be a solid area, and I don't know what the top looks like, but that, okay. So the volume of this, the volume of the solid under z is equal to x squared plus y squared and over the region written as the Cartesian coordinate. It's a square region from 0 to 1 to 0 to 1. This is called a unit a square. Okay, that's what this represents. And of course, this is an easy one to do. I mean, you try to do this. You want to do this? Maybe I should do that. Okay. Because this is also a good illustration of what happens here with x and y. You have to be careful, right? Remember, you have to fix one of them as a variable, as a constant first. When you're doing this with respect to y, this becomes x squared y plus 1/3 y cubed. Get that? Okay, that is the antiderivative of this with respect to y, right? And then you integrate this from 0 to 1. Now, y is going from 0 to 1. X will remain the same, right? So this becomes x squared plus 1/3. Did you get that? Because when you plug in y is equal to 1, then this becomes 1/3, this becomes x squared. And of course, when you plug in 0, they both become 0, right? And so this becomes 1/3 x cubed plus 1/3 x. And you go from 0 to 1, making sure that the derivative of this is x squared and the derivative of this is 1/3, which is exactly the case. So this is 1/3 plus 1/3, and it's 2/3. Okay, so this is the kind of thing you do for your homework. I have one more example of a slightly more difficult function, derivative, antiderivative. And what you need is maybe you need to go back and look at the list of integrals, list of antiderivatives, just so you can get used to it. I expect you remember how to do u substitution. I am sure you will need to use u substitution somewhere in the homework set for this first section. All right, so here's the question that I wanted to ask you. X over y, dy dx. Okay, first of all, what's the region here? The region R looks like this. X goes from 0 to 1, and y goes from 1 to e, which is like 2.7 something, right? So it's going to be this region that we are integrating over, right? And the integral is x over y. Maybe it's not so simple, right? Or is it, right? So what happens when you integrate this with respect to y? Remember, x is constant. And so you're basically integrating 1 over y with respect to y, and that becomes log, natural log of y. Plug in 1 and e for y, right? And so x stays the same, and this becomes log of e minus log of 1. I hope you know what they are. The natural log of e is 1, and the natural log of 1 is 0. So this is simply the integral of x dx from 0 to 1. And so the integral simply just becomes 1/2. Okay. You can switch the order. You should be able to switch the order. And if you're asked to do this in the other way, in dx dy, in that order, then you just change the numbers. And so it becomes dx dy, and the outside and inside bounds will switch with each other. And so what is the antiderivative of x over y with respect to x? 1 over y stays the same as a constant, right? And x becomes 1/2 x squared. Plug in 0 and 1 here. You can even do this, and this will be 1/2 and then 1 over y dy. You can take out 1/2 in front if you like. And the integral of y, dy over y is, of course, the natural log of y, going from E1 to E. And as before, this becomes natural log of E minus the natural log of 1. And this is, of course, 1 minus 0. And so the answer is 1/2. Okay, so again, try to practice. And I have given you enough practice. Some of the numbers are a little uglier, but nothing is too difficult for section 1. Okay, so I think you have like 14 questions to do for this section, and you should be good. Just practice, switching the order, visualizing what you're doing, and you will be fine with this first portion of multiple integration. Next, we'll go into more general regions where the region is not rectangular. But until then, I hope you have a great week. I'll talk to you later. Bye.